with lines and planes, how to name them, and now we're drawing them. So on this one, this last example that we did not get to, is that correct? I want you and your partner right now to go ahead and draw and label a ray that has endpoint M and contains point N. And your picture should have a point N already on it. So you have N somewhere on your picture. Go ahead, draw a ray, endpoint M, that contains N. Be careful, the end point is M. So make sure that you have your end point as M. Read very carefully. Okay, I'm seeing a lot of good and just a few that were wrong there for a second. So you should have had a point somewhere. Does not matter where you put point M, but somewhere you're going to put point M, and that's where you're going to start. That's your end point. And it's going to go through N, and you should have an arrow on the end. Remember, rays go on forever in one direction. Any questions so far? Okay. Postulates. We're going to learn 5 postulates in this section. Another word for a postulate is an axiom. I'd never heard that word until I got to college and my professor started talking about axioms, and I was like, what's he talking about? Just postulates. So if you hear that word, it's just another word for postulate. A postulate is what I think of as common sense. When you read it, if you look at it and think about it, you're going to be like, well, yeah, that makes sense. Most of our postulates we learn are not super complicated. They are just things that you probably already expected to be true. The definition for them is they are statements that are accepted as true without proof. If you've talked to anybody in geometry that's had it before, they'll probably tell you that geometry is terrible because of proofs. A lot of students don't like doing proofs. Proofs are a little bit tough at first, but we'll get really good at them. We aren't working on proofs right now. It's ways off, so no worries. But postulates are things that we're not able to prove true. Nobody has proven them true. We just accept them as true. But again, you'll see they're pretty much common sense. So the first 3 we're going to talk about is through any 2 points there is exactly one line. That's our first postulate. Think about it. If you draw 2 points on your paper, how many lines can you draw through those 2 points at the same time? 1. There's only one line that can go through those 2 points at the same time. Does that make sense? Okay. Number 2, through any 3 non-collinear, remind me, what does non-collinear mean? They don't make a straight line. They're not on the same line. So through any 3 non-collinear points, there is exactly one plane. So again, think about that. We talked about this last class. If I put 3 points on the board and they're not in a straight line, then the only plane that can go through those 3 points is the whiteboard. If they were in a straight line, then we could have a plane that's going out this way through those 3 points, right? Okay, but through any 3 points, doesn't matter if they're in a straight line or not in a straight line, there is definitely a plane that will contain them. So they will be coplanar, okay, through any 3 points. Number 3, if 2 points lie in a plane, then the line that contains them lies in the plane. So think about that again. If you take a piece of paper, this is your plane. If you draw 2 points on your plane, where is the line going to be when you connect those 2 points? On the plane, right? On the paper. So would you agree that those are kind of common sense when you look at them? You don't have to memorize these postulates as far as being able to write them out, but you need to know whether or not, if I give you a statement on a test, would it be true or false? So through any 2 points, there's only one line. Through any 3 points, there is always a plane. And if 2 points are on a plane, then the line that you connect them with will be on the plane. Okay? I'm going to skip this one. Actually, I won't. Let's review this real quick. It says, name a line that passes through 2 points. Remind me, correct notation. How do we name this line? XY. And a line above it with 2 arrows on the sides. Could I call it YX? Yes. Okay, good. So remember, notation's going to be huge. Little simple things you may be going, this is too easy, I got it. But it's really, really important. All right, remind me how to name a plane. It says name a plane that contains 3 non-collinear points. How could we name this plane? Plane R was one way we talked about. Looking for that cursive letter in the corner. What's another way we could name this plane? Perfect. Plane, and then remember that you pick 3 points. Don't use R because R is not a point unless you're just using R. Pick 3 points. The order doesn't matter. GHF. Any questions on how to name the plane? Do we ever use this little N to name the plane? No. What could we use that little N for? To name the line. Okay? All right, I'm going to skip this for now. Let's go on to the next 2 postulates. So the last 2 in this section says, if 2 lines intersect, they intersect in exactly 1 point. So think about that with me. If I draw a line on the board, and then I draw a different line on the board, and they intersect each other, would you agree that they're only going to intersect at 1 point? Is there any way for 2 different lines to intersect at more than 1 point? No. If they were the same lines, if you remember back in Algebra 1, you guys solved systems of equations, and you did that with substitution, elimination, you did it by graphing. If they turned out to have infinitely many solutions, do you remember solving systems and the answer was infinitely many? Okay, that only occurred when it was the same line. It turned out that when you graphed it, the line and the line landed right on top of each other. They were the same line. So this is saying if they're 2 different lines, they can only intersect at 1 point. Okay? They may not intersect at all. What do we call 2 lines that never intersect? Parallel. Okay? But if they intersect, only 1 point. Okay, think about 2 planes. Think about 2 walls in this classroom. When 2 planes intersect, where do they intersect at? What shape do they make? They don't intersect at a point. Where do they intersect at? A line. They intersect in exactly 1 line. If you think about this wall and this wall, they're touching all the way down that line segment, right? And planes go on forever, even though our classroom walls have to stop. So they actually intersect at a line, not a segment, because they go on forever. Okay? And a lot of times if you're confused on a question, if you'll try to look around in your environment and look for a line or a point or a plane, you can probably visualize it just in your surroundings to help you answer the question. Okay, super important. I counted off. My class that's double blocked and is doing geometry in a semester has already turned in their first assignment. And last night when I was grading a few of their papers, they messed up on this part. So super important. You have to use a dashed line in order to show the parts of your figure that you cannot see. So for example, if I have this plane, remember a piece of paper is like a plane, and I have this pencil, which is a line. If my line is in my plane, then it's just laying right in the plane. So I can see my entire pencil. Would you agree you can see the entire pencil if it's in the plane? Okay, but if it intersects the plane, then it's going through the plane. So if I push my pencil through my plane here, now can you see my entire pencil? No. So in order to get that 3rd dimension on your 2-dimensional piece of paper that you're doing your drawing, you've got to use those dashed lines to show the parts you can't see. So if I wanted to draw this on my piece of paper, I would start by drawing a plane, and anytime you draw a plane in here, you're going to draw it like a parallelogram. Okay, so this is our plane. I want my pencil, I can see the top part of my pencil, but at some point when my pencil went through my paper, I no longer could see it. So when I can't see it anymore, I'm going to put dashes. Does that make sense? If my pencil had been long enough, would you have been able to see it again underneath the paper after the paper stopped? So then that means once it comes out through the paper, down here at the bottom, it should be solid again. Does that make sense? Okay, so you're going to use dashes. Another way you could use dashes is if you're drawing three-dimensional shapes. So maybe a cube. You can use those dashes to get that third dimension in the background, the sides that you can't see. Does that make sense? All right, let's see how you do. You and your partner go ahead and try to sketch the next 3 questions, which should be the last 3 questions. So there's A and B here, and then there's one more on the next slide. Do you see that there's 3? So go ahead and see if you can draw all 3 pictures. So I saw some great answers on the first one as I'm walking around. Just 2 lines that intersect in 1 point. Don't forget when you draw lines, this would not be correct. What am I missing? Arrows. If it says segment, then what I had drawn would have been okay. But need arrows, and they intersect at 1 point. So they're just crossing at 1 point. Any questions on the first one? Second one, sketch a figure that shows a line that lies in the plane. That's the key word there. So remember, to draw your plane, you're just drawing a parallelogram. And then you have a line that lies in your plane, so you can see the entire line. It's just solid. Any questions on that one? Okay, it's the next one that I was seeing quite a few either blanks or not really sure what to do. This one's kind of wordy, so let's go through it together. Sketch a figure that shows 2 lines. So definitely look at what you have drawn. Do you have 2 lines drawn? They intersect in 1 point. So make sure that they're intersecting in 1 point. They have to intersect at that 1 point in the plane. So that means that point should be in your plane. But only one of the lines lies in the plane. So only one of them should be completely solid. The other one has to be intersecting it, so it has to be going through the plane. So I would probably start by drawing my plane. I would draw the line that's in the plane. And now I have to have a second line that's going to intersect this line at 1 point in the plane. So pick a point where you want it to intersect the line. And then draw a second line intersecting it. But once it intersects it, it has to be dashed, because now you can't see it. It's going through your plane until it comes back out, and then it should be solid after that. Questions on that one? All right, any questions on points, lines, planes, section 1-1? Okay, homework. You have a homework assignment from last class period, right? That is due when I see you on Tuesday. Okay, that's your first assignment. That's due on Tuesday. We're going to go ahead and move on to section 1-2. You will get a second assignment today, but it won't be due on Tuesday. It'll be due on Thursday. However, I would encourage you to go ahead and do the first page on it, because the first page is what we're going to go over in 1-2. That way on Tuesday, you're not stressed out when you get another assignment on top of it, okay? So you've got the one, hopefully you started it, that's due Tuesday. Awesome. And then you're going to get the second one in a few minutes. It's going to have 2 pages on it. We're not going to get to the second page notes today, but we will hopefully finish the first page of notes. And we'll see if we get very far into the second one. Okay? Any questions about what's due Tuesday? All right, and I'll keep sending out those reminds to try to remind you, so you'll know this one's due Tuesday, this one's due Thursday, but best advice I have is when you get these little blue slips, write on there, due whenever, so you'll know, kind of not get behind and be on track. Okay, so 1-2, make sure everybody has a set of 1-2 notes. Did I miss anybody or count wrong? Okay. So this section is where we are going to start talking about finding midpoint, distance, the length of something, but we're going to start out real basic. We're not talking about Algebra 1 where you had 2-dimensional XY axis coordinate plane. We're talking 1 dimension on a number line, simple distance. Okay, really easy stuff to start out with. Lots of vocabulary again. First thing we're going to talk about is the definition for coordinate. We'll be using a ruler sometimes, but very little. A lot of the times what we're going to use is actually formulas, algebra to solve for distances and measurements. But a coordinate, you're probably thinking of a coordinate as what you left off with in Algebra 1, which would be an ordered pair like this, right? We're going to go back even more basic today and think about just a number line. And so we're saying that a coordinate for point A is the number 1. Okay, so one-dimensional, every single point has a coordinate. So this just simply says a point corresponds to one and only one number on a ruler, and that number is called the coordinate. So it's just the number that corresponds to a point. Every point has a number. There's another point right next to this, infinitely small. That's why points have no dimension. That is at 1.00000001, right? So really close. But every point can be identified by a number, a coordinate. The ruler postulate's not a postulate that you need to worry about memorizing or really even need to know, but it's in our book, so I'm just going to point it out, and it just simply says that when you have a ruler, every single point along that ruler can be identified by a number. So just like that. Okay, so let's talk distance. Again, super simple distance. Right now, we're just talking about one-dimensional distance. So on a number line. So if I have a point at A here, and then I put another point up here at B, what is the distance from A to B? Careful. What's the distance from A to B? 2. 2. Remember, you do not count where you start. You're talking about the distance. So from here to here is 1 unit. From here to here is 2 units. So my total distance is 2. Okay. Length. So this is 1 unit. This is 2 units. So to get from 1 to 3, it's 1, 2 units. Okay. Or, because a lot of students over the years of me teaching make a mistake when they're trying to count the distance because they want to start where their point is. The definition for distance is actually the absolute value. What's absolute value do to a number? In Algebra 1, what did absolute value do to a number? It made it positive. So remember, absolute value are these little straight lines. Remember those straight lines from Algebra 1? Absolute value makes it positive. So the distance will always be positive. You'll never have a negative distance. If you get a negative distance, you've done something wrong. It's the absolute value of the difference. What does difference mean to do in math? Subtract. So it's the absolute value of the difference of the coordinates. So another way you could work it is to say, I'm going to subtract 1 minus 3, where the 2 coordinates are, but take the absolute value. What's 1 minus 3? Negative 2. And then what does absolute value do to that? Makes it positive. Now you may be thinking, I don't need to do that. I can just count. That's simple. That's great as long as these are simple numbers. But if this was 1,243 and this was 3,562, you're probably not going to want to count all the little tiny tick marks between there, right? So the quicker way to find the distance would be to simply subtract them. And it doesn't matter the order you subtract because the absolute value is going to make it positive either way. So you could do 1,243 minus 3,562, and then take the absolute value of that number. Does that make sense? Okay. Now, you may be thinking, what about a calculator? Because as they get bigger, you're probably going to want a calculator. So, just a heads up, I'm going to be really bad about this because you're my only class that's not pre-AP. And so in pre-AP, I'm a little bit tougher on them, and I don't let them have a calculator for the first whole semester. So this is usually going to be shut because of that. But you guys can have a calculator all the time. So this will be open. I mean, you can just come open it up. It's always unlocked, just so you know. So when you get here in the mornings, just come in and grab your calculator so that you'll already have it for the day. But this side won't open. The left side will. So if you'll open the left side, and then there's a little switch over here that you can click to open the other side. I'm not going to worry about assigning calculator numbers unless I have an issue. So if you are careful with your calculator, you don't tear it up, nobody's writing all over it or doing anything, then I'm just going to let you grab whatever calculator you want. As soon as I see that one's been damaged or something's happened, then I'll have to start assigning numbers. Okay, so hopefully we won't need to do that. You can just grab a calculator. Are we good? Okay. So distance. Distance, another word for distance is length. So they may ask you to find the length of a line segment. If they ask you to find the length of the line segment, they're just asking you to find the distance. And again, you can either count it or you can do the absolute value and subtract. Here's the thing that a lot of students make a mistake with, and it's me being very picky, so I'm going to warn you. On a test, it may say, find the length of AB. What does this mean? Say it again. Line segment AB, right? It's just a segment AB. When you write your answer, though, you're telling me the answer to the distance. Distance is written as two letters side by side with no line above it. Distance is a number, not a shape. So when you write your answer, you are not going to put AB with a line above it. You're just going to put AB equals and then the answer. That means the distance from A to B. You might have problems on your homework that just simply says this. And you have to know that means find the distance from A to B. Okay? I will be really picky about that line segment. I will remind you on your homework over and over again without counting off points, but by the time we take the test, I'm going to expect you to have figured it out by then. Okay? So if I'm grading your homework and your answer is correct, but you keep putting that line above it, I'm going to circle that line and put a little mark through it, like don't do that, to try to remind you until it's the test day. So be really careful. Segment if it's a picture. No segment if you're telling me what the number is, because it's distance. Okay, easy ones here. Let's just do these together. What is the distance from B to C? 2. And again, if you want to do absolute value, you could do 1 minus 3 again. That's negative 2. Absolute value makes it positive 2. What about A to C? 5. Again, if you're doing, if you want to do absolute value, you can do negative 2 minus 3. And then absolute value, what's negative 2 minus 3? Negative 5. And then the absolute value makes it positive. Okay, and you will, again, have a calculator, so if there's anything that you're not sure about, you can always check it on your calculator. We're going to skip the next ones, just to go a little faster, and move on to congruent segments. So if you'll flip in your notes to where we are here, congruent segments. Okay, congruent segments are segments that have the same length. When you see two segments in geometry, first of all, never assume the picture is drawn to scale. Every year I have students go, well, it looks like a 30-degree angle. How can it be 150 degrees? Because they're going to purposely not draw the pictures to scale sometimes. They're going to check to see, are you doing the math correctly, not just looking at the shape and trying to measure it with a protractor. So be careful that you don't assume anything about your picture. Only what's been given to you that you know for sure to be true. So if they're congruent segments, then that means that they're going to have the same length. Congruent means same length. To show you that they're congruent, they're going to use what are called tick marks. If they have the same number of tick marks, that means they're the same length. If they're not the same length, then they may use a different number of tick marks to show you that they're not the same length. Okay, so look for those tick marks because they're going to give you information in your picture. The symbol for congruent looks like an equal sign with a little squiggly above it. That's what we're going to use to show that things are congruent. Here's another really picky notation. It goes back to this idea of shape versus number. Okay, so here's the big picky thing. If I'm talking about the distance from P to Q, I should not have a line segment above it. Distances are equal. I'm going to write that down. If I were you, you may want to make a note to yourself on your notes. Distances are equal. So if I want to say that two distances, two numbers are equal, remember a distance does not have a line above it. So PQ is equal to RS. But if I'm talking about the shape, the actual line segment, shapes are congruent. Shapes can be congruent. So numbers are equal, shapes are congruent. So then I would put lines above them. I would say PQ with a line segment is congruent to RS with a line segment. Do you see the difference? If you're saying congruent, the shapes are going to be congruent, so the segments are congruent. If you're talking about the number or the distance, then you're going to use equal signs and you would not have lines above them. Okay, another way to think about it would be I'm adding something above it when I'm adding something above the equal sign. All right, that's the thing I see a lot of mistakes on, so I'm going to be kind of picky and say it over and over again. Constructions, this is where your compasses are going to come into play. We hopefully will get to do some constructions this morning and play with the compasses. And constructions are a great way to make sure that your picture is drawn precisely. So a construction is a more precise way of creating a figure. The only thing about a construction is you can only use two tools. When we do a construction, you're only going to get two tools for that construction. One of them is a compass. And remember, that's not the north, east, south, west. That's the thing that makes circles, and that's also on your supply list. If you haven't bought a compass yet, keep in mind if you end up having homework that says construct something, you're either going to need to go get a compass or make sure that you have come in before the homework's due and use the ones at the back of the room. And I'm always here at 8 o'clock in the morning if you need to borrow one. Straight edge is the other thing that you're going to get to use for a construction. Now, a true straight edge would have no numbers on it. This would be a straight edge if I look at it like this. You're not measuring with constructions with numbers. You're not using a ruler to measure anything. The only way that you get distances measured is with the compass. You'll be opening your compass and closing it to measure things, not a ruler. But I didn't go out and buy straight edges that were blank when we have access to rulers. So we'll use our ruler for the straight edge part. You'll just ignore that there's numbers on it. And I'll know if you try to measure with your ruler, because then you won't have the little arc marks that you should have. I don't have my compass out. Yes, I do. With your compass, I should see little arc marks on your paper. And so if you construct it, I'm going to know because you're going to have these little arc marks. If you use your ruler to measure, you won't have that. So only using the blank side, or ignore that there's numbers on your ruler when you're doing a construction. Okay. All right, the first most important postulate we're going to learn and we'll use over and over again all year long, segment addition postulate. You will need to memorize this name. Okay, segment addition postulate. Segment addition postulate. Here's what it says, and again, postulates are pretty much common sense. So they're not really hard as far as the concept goes. Segment addition postulate says if you have a line segment, then part of the line segment, AB, addition, so plus, the other part of the line segment, BC, should equal the whole line segment, AC. Or another very simple way to say it would be part plus part should equal the whole. And that's all it says. Part plus part equals the whole. So what we're going to have, we're going to have some pictures where we have to find missing measurements, and we're going to use that idea of part plus part equals whole. Is that your phone, Jackson? Make sure and put it in your bag. It shouldn't be out. Remember, phones are... It's not allowed in your lap, though. Make sure it's put away. Thank you. Everybody with me? Part plus part equals whole? Okay, so we're going to look at some problems. My advice, best advice for this year, when you get to a problem that's a word problem, draw yourself a picture. If you'll draw a picture, it makes the words come to life. You can see it better. I'm a very visual learner, so for me, I need that picture. If you don't need a picture, that's great, but they're going to get harder as we go throughout the year, and pictures really will help you. So G is between F and H. So what are we going to draw on our paper? Very good. We're going to draw a line segment where we have G somewhere in between. Does that mean G is in the middle at the midpoint? No, just somewhere. It could be, but it doesn't necessarily have to be. It's just between them. So G is going to be somewhere between, and then your endpoints will be F and H. And again, that order doesn't matter. Then you're going to label. What do they tell us that the distance from F to G is? 6. Then they tell us that F to H, which is the whole thing, is 11. So I would draw myself a picture, then it becomes a little easier to see. The question is, find GH. And what does it mean again when two letters are side by side? Nothing above it? Distance. So they're asking you to find the distance from G to H. What would the distance from G to H be? 5. How did you get that? You just said 11 minus 6. If you aren't sure whether or not you're supposed to add or subtract, then you could set up the segment addition postulate. You don't have to write it out this way for these easy ones, but if you need to, feel free to. You could say part FG plus part GH equals the whole FH. And then plug in your numbers. 6 plus, we don't know what GH is, equals 11. Now we have an algebra equation. In order to get GH by itself, we've got to subtract 6 from both sides. So GH is 5. And then remember, do not put a line segment above it. You're telling me the distance, which is a number. Easy with numbers? Okay, let's step it up a little bit. Let's throw in some algebra. And what you'll notice in geometry is that we learn a geometry concept and then we apply our algebra to it. So that's why Algebra 1 is required before geometry. We'll use a lot of algebra in here. Okay, M is between N and O. They gave us a picture this time. Here's N and O. M's somewhere between there. They've already labeled the picture with everything. They want us to find NO. What could we write down as an equation to help us find NO? Using our segment addition postulate. Very good, Reese. NM plus MO should equal NO. Part plus part should equal the whole. So N to M is part, M to O is the other part, should equal NO. Now plug in what those things are equal to. What is NM in the picture? 17. What's MO in the picture? 3x minus 5. Add them together. That should equal, what is NO? 5x plus 2. Notice this is going all the way across here, which means that's the whole distance, 5x plus 2. Okay, and now we just have an algebra equation we need to solve for x. What could we do over here on the left to make this more simplified? We aren't really adding 5 because it's on the same side, right? We're going to combine those like terms. So what is 17 and negative 5? 12. So we do need to combine those like terms, but it's on the same side of the equal sign, so we just combine them, subtract. We get 3x plus 12 equals 5x plus 2. Okay, what do you want to do from there? How do we solve for x? Subtract 2. So now we have 3x plus 10 equals 5x. What do you want to do from there? Subtract 3x. So now we have 10 equals 2x. Now what do you want to do? Divide by 2. So x is equal to 5. Is that our answer? No, that's x, but what did they ask us to find? NO. And what does this mean again? The distance from N to O. So they want us to find the whole distance from N to O. What expression represents NO? Oops. What is NO equal to in the picture? 5x plus 2. So what are we going to have to do? Plug in 5 for x. So we're going to put that 5 in for x. So we have 5 times 5 plus 2, which is 27. So NO is 27. Do not put a line segment above NO. You're giving me a distance, which is a number. Segment addition postulate. Does this make sense? Part plus part equals whole. Okay, we're going to do something a little bit different, but on the same track here. We're going to talk about midpoint. If I go too fast, slow me down. Does anybody need more time here? Okay, give you just a second. All right, so get to the next one. So let's talk about midpoint. Between, remember, does not mean in the middle. It just means it could be anywhere along that line segment. But midpoint does mean that it's going to be in the middle. However, I do not want you to tell me that the definition for midpoint is the middle. That will not help you when we get to proofs. Super important that you know the real definition for midpoint. The definition for midpoint is it is a point, first of all. It's just a point. It's a point that bisects. Bisects means to divide into two congruent segments. So the definition for midpoint is it's a point that splits a segment into two congruent pieces. In other words, if I were to draw a picture here of AB, my midpoint M is going to split AB so that AM is the same length as BM. Okay, it's going to bisect or divide that line segment into two congruent pieces. So if this whole thing is 6, what is AM? 3. What is BM? 3. When they tell you it's a midpoint, you know you can go to your picture and mark the pieces congruent. That means you know that it's going to split it into two halves, two congruent segments. Again, notice the notation. The distances are equal, no line segments. I'm going to skip this example and go to, not this one, oops, sorry, this one. So find this example. And one thing I should have told you guys from the beginning is I use the same sets of notes for regular geometry as I do for pre-AP, but we will oftentimes skip some of the harder examples that are more for my pre-AP classes that won't be on your tests. So when I said let's just skip this, it's because we're not coming back to it, okay? So just don't worry about it, ignore it. You're welcome to try it on your own if you want to later, if you just love math and want to do more of it, but that's something that we're not going to have to worry about. Okay, so look at this example number 5. What does it tell us at the very beginning? D is the midpoint. So what does that mean to us right now automatically about our picture? If D is the midpoint. Very good. ED and DF are equal, which means I can go and put little congruent marks, maybe, or not. I don't know why my board keeps messing up. It did it the first day too. Let's try again. I'm sure I touched something. I just don't realize I've touched. I don't know. Oh, what did that do? That wasn't good. Anybody know what I'm doing? Because I don't know what I'm doing. Go for it. I don't know. I'll pull it back up over here. Oh, it's marking over here on my picture, so it's not marking over there. Here we go. Let's try again. There it is. Look how many times it showed up. Perfect. Thank you. So you don't have to put 3 marks, but you could put 3 and 3. But you can at least mark your picture, right? So mark it so that it shows you that they should be congruent. When is the only time that you know for sure that they're congruent? Okay, when they're equal, and what word told us they were equal? Midpoint. So don't just assume it. You have to have that word, okay? If it's the midpoint, it's going to split it into two congruent segments. Okay, so we talked about segment addition postulate, which was part plus part equals the whole. Do they give us what the whole thing is here in this picture? No. So if we tried to solve this problem by doing part plus part equals whole, we wouldn't be able to because we don't know the whole thing. So instead, what do we know about 4x plus 6 and 7x minus 9? They're equal. So we can just set them equal. 4x plus 6 equals 7x minus 9. So if they tell you it's the midpoint, you do not have to set up part plus part equals whole. Does that make sense? And then let's solve. What do I do here to solve? Subtract the 4x. So now I have 6 equals 3x minus 9. What about from here?
Just a reminder, please do your enrollment count to the admissions office at this time. Thank you.
Guys, go ahead and finish that problem. Solve for x and then answer the question. Okay, let's see. What did you guys get for x? 5. We add 9. We have 3x equals 15. Divide by 3. X is 5. Again, is that our answer? Not for this one. If it just said find x, it would be your answer. But it said find ED, DF, and EF. So we've got 3 answers that we have to list on our paper. Let's start with ED. ED is 4x plus 6. So plug that 5 back in. What's 4 times 5 plus 6? 26. Do you really have to plug the 5 back in to find DF? No, because we just said they should be what? Equal. So you could just put 26. If you did it correctly on the first one, your second one should be right. You could plug it back in, though, just to be sure in case you made a mistake. And then what do we need to do to find EF, the whole thing? Add them together. What is 26 plus 26? 52. And then you'll write your answers. No line segments above them because we're talking about distance. Any questions? Is everybody good? All right, that's 1-1, 1-2. Let's talk about some constructions. We could go on to 1-3, but I don't want to overload you with too much information today. So